Okay, so we have to start somewhere as we start our semester of algebra. And we're going to start in chapter 1. And so some of this may be review, some of it may be new to you. It talks about being the essentials of algebra. I wouldn't worry too much if you don't remember everything, but this is just going to start us out with some vocabulary and some tools that we're going to need. So the first thing we're going to talk about are sets of numbers. So the first set of numbers that you learned were probably the set of numbers, get this going, 1, 2, 3, and so on. Those are called the natural numbers. So when you were little, maybe grandma was counting with you and she started with 1, right? She didn't start with 0, she didn't start with any negative numbers. First set of numbers, 1, 2, 3. In fact, these are not only called the natural numbers, they're also called the counting numbers. So sometimes you'll see them called the counting numbers or the natural numbers. Okay, and then they're going up on and on until as high as you can count. That was your first set of numbers. The next set of numbers we're going to talk about are the whole numbers. So the whole numbers, they're the natural numbers, but also 0. So maybe around kindergarten, they talked about my hero 0, and they taught you about what 0 meant, okay? So the whole numbers are all the counting numbers or natural numbers and 0. So when we talk about sets of numbers, the whole numbers includes all of the natural numbers and 0. Okay, and then at some point they wanted you to learn about integers. Now integers are the whole numbers, so 0, 1, 2, 3, and so on. 4, 5, 6, on like that. And they're opposites. So -1, -2, -3, and continuing on to smaller numbers as far as you want to go. All right, to infinity and beyond. By the way, infinity is going off in this direction. Negative infinity would be going off in the other direction. So sometimes we'll make a number line. I always think of that for students. When you make a number line and you put 0, 1, 2, 3, however you're going to do it, and -1, -2, -3, you're looking at those little tally marks as kind of where you're making the integers. And sometimes students like to put, infinity on this one and negative infinity here so they remember which one's going which way. Now on a number line, you're always going from smallest to largest from left to right, okay? Those are the integers. All whole numbers are also integers. All right. Then we have what are called the rational numbers. A rational number is any number that can be written as A over B, where A and B are integers. I'll just put are integers. There's different notations we can use, but I'm just going to try to keep it simple here. So you can take any whole number and put it in A over B. Like let's say you have the number 17. That's a lovely whole number. It's also a natural number. It's also an integer. But you could write it as 17 over 1, and now it's in the form of a rational number where you have A over B. Now when we're simplifying, we write 17. But if you wanted to see it in the form of A over B, you could write it as 17 over 1. Sometimes we do that when we're working with fractions, right? Okay, now, so rational numbers include fractions. You could also have a fraction like a mixed number, like 3 1/3. Now, just a little review here. How do you change that to what we call an improper fraction? Remember, you multiply 3 times 3, and then you add the numerator. So 3 times 3 is 9 plus 1, which would be 10 over 3. Now, this is called a mixed number because it's a whole number, 3, and a fraction. But 10/3 is a fraction. It's called an improper fraction. I'm giving you probably more words than you need. It's an improper fraction because the numerator is bigger than the denominator, okay? Now, in the world of algebra, we like 10/3. It's easier to read what's going on with it, okay? Now, you go to the store and you want 3 1/3 yards of fabric or lumber, they're going to want you to say 3 1/3. They're not going to want you to say 10/3. That'll like throw everybody off. Okay, so we use mixed numbers, but for our purposes, when we have a fraction that's 10/3, if we've simplified it, we can leave it as an improper fraction, okay? All right, let's see if there's anything else I want to talk about. Oh, decimals, right? Okay, so you can have a decimal like 0.25, and you could write that as a fraction, right? That would be 25 over 100. So you go by, tenths, hundredths, and so it's 25 over, oops, sorry about that, 25 over 100. But then you'd have to simplify that by, we say, reducing the fraction or thinking of a number that goes in both the numerator and the denominator. In this case, 25 goes into both the numerator and the denominator, and you would get 1/4. Now that's how we would write it as a fraction. All decimals, sorry, I have a little cough. So all decimals that terminate, like this one, it terminates, 0.25, it stops. That can be written as a fraction, so it's a rational number. You could have something like 0.1349, but it stops. That's a terminating decimal. It could be written as 1349 over, let's see, tenths, hundredths, thousandths, 10,000ths. Okay, now that looks scary right there, right? Like that's a scary number, but I have a little trick for you. So if you're thinking, oh, how am I ever going to reduce that large number? I don't know what goes into 1,349. I don't know what goes into 1,349 either. I just made that number up. But I do know that 10,000 is only made up of tens, right? And each 10 is 2 times 5. So only 2s and 5s or multiples of those are going to go into 10,000. So does 2 go into the numerator? No, it's not even. Does 5 go into it? No, it has to end in 5 or 0. So it doesn't simplify. So that's a little trick for you. When you have a number that's base 10 here, some power of 10, then the numerator has to be divisible by 2 or 5. Now it might go in, 2 might go in several times, or 5 might go in several times, but if 2 doesn't go in and 5 doesn't go in, then you're not going to simplify that. Okay, but my point is those are all rational numbers. Now, we also have decimals that repeat, like 0.777, and the 7 goes on. They write it that way, or sometimes they'll write it 0.7 and they'll put a bar over it. That means the 7 is repeating. Any repeating decimal is also a rational number. So these are all rational numbers. Now you might be saying, well, how are you going to turn that 0.777 into a fraction? We have ways of doing that, but we're not going to cover it in this class. Just know if it's a repeating decimal, it can be written as a fraction. Okay, and these are called rational numbers. Now, we have other sets of numbers, but for now, this will be enough to get us started. So coming back up here to my sets of numbers. First set, the natural numbers. Next set, and put a little box around that. The next set is the whole numbers. Oops, whole numbers. The whole numbers include all of the natural numbers and then 0, right? Okay. Next set we talked about were integers. The integers include all the whole numbers and their opposites, or the negatives, of them. And then we have the rational numbers. Rational numbers include all of the integers, plus then you've got those fractions and those decimals that either stop, terminate, or the decimals that repeat. This was a really long video, and I'm sorry, I'll try to make the next one shorter.